I'm going to go over the practice exam. Before you watch this though, make sure you went over the practice exam yourself. As it says in the instructions here, you want to treat this like an exam. Take some time aside and work through these problems as if you were taking the test. No notes, no calculator, no outside help. Set a time limit for yourself of 70 minutes. And then after you're done with that, then watch this or fast forward through this, check your answers, make sure you did it right. Okay, so the solution, it says solutions are posted online, can be found through the homework calendar. That's what this video is about. So don't watch this video ahead of time, watch it after you've actually taken that practice exam. Okay, start with number 1. So we have a parallelogram, and we're looking at measure of angle ADC, this big angle here, and DCB, this big angle here, and those are consecutive angles, and consecutive angles are supplementary. And so you're going to take those two angles, measure of angle ADC, plus the measure of angle DCB, add them together, set them equal to 180. That's what we mean by supplementary. So x squared plus 2x plus 20 plus x plus 160 is equal to 180. Adding this up, we get x squared plus 3x plus 180 is equal to 180. Subtract 180 from both sides of the equation, and you get x squared plus 3x equals 0. Factor, I'm using the GCF factoring. Separate your factors, set them equal to 0. You get x is 0, and x is negative 3. Number 2, we're told it's a rhombus, and we're solving for x. If the measure of DAC, angle DAC, is 20 degrees, I'll write that in there, and the measure of BDA, right in here, is your other angle. So a couple things that I can put here. So we know that the measure of angle DAC plus the measure of angle AED plus the measure of angle BDA is equal to 180 degrees, because the sum of the interior of a triangle is 180 degrees. We know that the measure of DAC is 20 degrees because they told us that. We know that the measure of AED is 90 degrees because the diagonals in a rhombus are perpendicular. And then we have an equation for BDA, that's 5x squared minus 17x plus 84. All that's added together, the three angles, adds up to 180. Combine like terms here, we got 5x squared minus 17x. Let's see, 90 plus 20 is 110. 110 plus 84 is 194, equals 180. Subtract 180 from both sides of the equation. To get 14. We are going to try the trinomial factoring here. So we're looking for two numbers that multiply, or two terms that multiply to 14 times 5x squared, which is 70x squared, and add to negative 17x. So negative 10x and negative 7x. Add to negative 17x, multiply to positive 70x squared. So I'm going to replace the negative 17x with both of those terms. And write 5x squared minus 10x minus 7x plus 14 is equal to 0. Factor by grouping. Factor out a 5x from the first two terms. Factor out a negative 7 from the last two terms. Both of these terms have a common factor of x minus 2, so I factor that out. What remains is the 5x minus 7. Set these factors equal to 0 and solve. You get x is 2. And x is 7 over 5. Number 3, we're told we have a rhombus. And we're looking at ABD right in here, and DBC right in here, and we know they're congruent because diagonals bisect opposite angles. That's true for a rhombus. Not true for any shape, but that's true for a rhombus, and we know this is a rhombus. So we have that the measure of angle ABD is equal to the measure of angle DBC. So 2x squared plus 5 is equal to x squared plus 6. Zero this out. Minus 6 minus x squared. And you get x squared minus 1 is equal to 0, which is a difference of two squares. So x plus 1 times x minus 1 is equal to 0. Set those equal to 0 and solve. And you get x equals negative 1 and x equals positive 1. 4, we're told that ABCD is a rectangle, and we're talking about angle ACB, this angle right in here, and DBC, and we know they're congruent because in a rectangle we have all four of these pieces from the diagonals that cross are congruent, so we get that isosceles triangle. So it really comes from two properties. Remember, the diagonals are congruent in a rectangle, and that the diagonals bisect each other. Because a rectangle is a parallelogram. So we can set the measure of angle ACB equal to the measure of angle DBC. So 4x to the third plus 8x squared is equal to x plus 2. Subtract x and 2 from both sides of the equation. And we get 4x to the third plus 8x squared minus x minus 2. Put it in order from highest power to lowest power. Use factoring by grouping. And we factor out a 4x squared. What remains is an x plus 2. Factor out a minus 1 from the last two terms. You get another x plus 2. Both these terms have a common factor of x plus 2. What remains is the 4x squared minus 1, which itself is a difference of two squares, so we got to factor one more time. And the square root of 4x squared is 2x. Square root of 1 is 1. One factor will have a plus sign, one will have a minus sign. You got your three factors now. Set them to equal to 0 and solve. And you got your three answers there. Number 5, we're told it's a kite, and a kite such that AB is congruent to AD. Okay, and so that means that DC and BC would be congruent, and the opposite sides would not be congruent. That's what we get for the definition of a kite. And we're talking about the measure of AED. That happens where the diagonals cross, and in a kite, it says to classify, but they already tell us what it is, so I didn't need to ask you that. But the diagonals in a kite are perpendicular. So I can say that the measure of angle AED is 90. So 343x to the third plus 26 is equal to 90. Subtract 90 from 26. We get 343x to the third minus 64 is equal to 0. Now 343 is 7 to the third power. 64 can be viewed as a perfect cube. It could be 4 to the third, and x to the third is a perfect cube. So we have two cubes here, and so we're going to factor it as such. The cube root of 343x to the third is 7x minus, because I'm using the same sign, cube root of 64 is 4. So 7x minus 4 is our first factor. To come up with the second factor, we take the 7x times itself. So 7x times 7x is 49x squared. And I'm going to use the opposite sign, which is a plus sign. 7x times 4 is 28x. Then it's always positive, so I put another plus sign. And then 4 times 4 is 16. That's how we factor it completely. Now when we solve, leave the 3-term factor alone and just use the 2-term factor. So the 7x minus 4, you set that equal to 0 and solve. And you get x is 4 over 7. And don't worry about trying to factor the other factor because it's not factorable. And don't try to worry about solving it either because I haven't taught you how to do that yet. On to number 6. Here we're told that the 4 sides are congruent. So what does that mean? That means we have a rhombus. So that's my classification. ADC is the big corner here. ABC is the big corner over here. Now because a rhombus is a parallelogram, opposite angles are congruent. And that's what these are. And so we can set the measure of ADC equal to the measure of angle ABC. So 2x to the third plus 3x squared plus 2 equal to x to the third plus 7x squared plus 2. Subtract x cubed and 7x squared and 2. And we get x to the third minus 4x squared is equal to 0. Factor using a GCF. So factor out x squared, you get x minus 4 remaining. So x squared is equal to 0 and x minus 4 is equal to 0. If x squared is equal to 0, that means x is 0. And x minus 4 equals 0 means x is positive 4. Number 7, we have all 4 angles, big angles congruent. That's a rectangle by definition. And looking at AE and DE, and we know those two are congruent to each other using two properties. First of all, well, we know all 4 of them are congruent to each other, and that came out of the diagonals of a rectangle are congruent, and the diagonals of a parallelogram, and a rectangle is a parallelogram, bisect each other. So put those two together and we conclude that AE, that length, is equal to DE. So 4x squared plus 5x plus 10 is equal to x squared minus 15x minus 2. So this equal to 0. And then go ahead and solve. So we going to factor using the trinomial factoring. So 3x squared times 12 is 36x squared. Want to add 20x. So you go through the factors of 36, and you'll find that 36 is 18 times 2, and 18x and 2x add to 20x and multiply to 36x squared. So you split up the 20x to 18x plus 2x. Factor by grouping. You get x plus 6 times 3x plus 2 is equal to 0. Set your factors equal to 0 and solve. So first factor is x plus 6. You get x is negative 6. Second factor is 3x plus 2. And you get x is negative 2/3. Number 8, AB is parallel to DC and AD is parallel to BC. So based on that, we know this is a parallelogram, because that's the definition of a parallelogram. Then we're talking about AE, BE, CE, and DE. Well, in a parallelogram, diagonals bisect each other. And so AE is congruent to EC because the diagonal DB cut AC in half. We can also say that DB is congruent to EB, but I'm just going to use AE equal to EC. AE is 20x squared minus 10. EC is 4x squared minus 9. Subtract 4x squared and add 9. And we end up with 16x squared minus 1 is equal to 0. That's a difference of 2 squares. So I factor it using that pattern, 4x times 4x is 16x squared. That's the square root of 16x squared is 4x. Square root of 1 is 1. Plus sign, minus sign, set each factor equal to 0 and solve. You get x is negative 1/4. And positive 1/4. Number 9, we have AD is parallel to BC. AB is not parallel to DC, so that's a trapezoid with call out base 1, this would be base 2, and we're looking at, they're giving information on 3 angles. DAB is this one here, ADC right here. Those are base angles. We don't know that base angles are congruent though, because it's not an isosceles trapezoid, it's just a trapezoid. And ABC, okay, so I circled the A and I circled the B. Those two are what we call same side interior angles, because they are touching different parallel lines and a common transversal AB between them. And so same side interior are always supplementary. So I can take those two angles, DAB plus the measure of the other one, which would be ABC, and I get 180 degrees when I add them together. So 2x to the third plus 6x squared minus 4x plus 76, that's one of the angles, plus 2x to the third plus 6x squared minus 5x plus 77, and all adds up to 180. Combine like terms. Subtract 180 from both sides of the equation, you get 4x to the third plus 12x squared minus 9x, and then 153 minus 180, sorry, 27, so negative 27. Factor by grouping, because we have 4 terms. First GCF is going to be 4x squared, x plus 3 remains, minus 9, x plus 3 remains. These two terms have a common factor of x plus 3. Factor that out, and we get a 4x squared minus 9, which is itself a difference of 2 squares, so we got to factor again. Square root of 4x squared is 2x. Square root of 9 is 3. And now we have it fully factored. Take your factors, set them equal to 0, and solve. Get negative 3. Negative 3 over 2. positive 3 over 2. Number 10. AB is parallel to DC. I'm going to do some scratch work on this one. Okay, so we have AB parallel to DC. Angle ADB is congruent to CDB. I'm sorry, I messed that up. Let me fix that. ADB, so this angle here is congruent to CDB. So those two angles are congruent. ABD is congruent to CBD. Because the top and the bottom AB and DC are parallel, we know that I'll call it angle 1 here and angle 2 here. Those are congruent to each other because they're alternate interior angles. And we already said that angle 2 and I'll call this angle 3 are congruent. So angle 3 and angle 4 must be congruent. So the left side AD must be parallel to BC. So we know that this is a parallelogram. Okay, now because we know it's a parallelogram, well, before we get to that, just want to point out something. AD is going to be congruent to AB because we know that it's that triangle DAB, the base angles are congruent, and by the converse of the isosceles triangle theorem, we get an isosceles triangle. And then because we know that we're working with a parallelogram, opposite sides are congruent. So AD is congruent to BC, and AB is congruent to DC. So all four sides are congruent. So not only is it a parallelogram, but we got now to a rhombus. So rhombus is the classification we need. Now our equations, BAC, okay, and ADB and so what I'm going to do here, just for the sake of ease, I'm going to erase my scratch work. I'm going to number these angles. Call this angle 1, angle 2, angle 3, angle 4. And I'm going to write the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is equal to 180. Because the sum of the interior of a triangle is 180 degrees. The measure of angle 2 is the same thing, is equal to the measure of angle 1, because in a rhombus, diagonals bisect opposite angles. The measure of angle 3 plus the measure of angle 4. Measure of angle 4 is going to be 90 because diagonals in a rhombus are perpendicular, and angle 4 happens where the diagonals cross. And so now the measure of angle 1, which was BAC, so this is the measure of angle 1 here. So that's 27x to the third minus x plus 218 plus the measure of angle 3. Angle 3 was the ADB, So that's the 37x to the third plus x minus 3 equals 180. 27 plus 37, 64. 218 minus 3 is 215. Subtract 180 from 215. And you get I am noticing that I forgot to add my 90 in here. So I should have a plus 90. There we go. Can't forget about that. So you got 215 plus 90, which is 305. And then the 305 minus 180. So we're going to get negative 125, no, positive 125 equals 0. That is a sum of two perfect cubes, because 64 is 4 to the third power and 125 is 5 to the third power. So I'm going to factor it as a difference of two cubes and get perfect. So the cube root of 64x cubed is 4x. Cube root of 125 is 5. We're using the same sign here. 4x times 4x is 16x squared, using the opposite sign, so minus sign. 4x times 5 is 20x, always positive. 5 times 5 is 25. So now it's factored. The 3-term factor you leave alone because it can't factor it anymore, and right now I'm not requiring you to solve that one. But the 4x plus 5, set that equal to 0 and solve. And you get x is negative 5 over 4. Alright, last one. We have a rhombus, we're told that. And solve a CAD, call that angle 1 here. And ACD, angle 2 here. Okay. So in a rhombus, notice that all four sides are congruent. So AD is congruent to DC, because really all four sides are congruent. Because it's a rhombus, and so we can, if I take half of this, we see an isosceles triangle. So angle 1 is congruent to angle 2. Okay, and so classification again, we didn't have to worry about this as a rhombus, and we're really using the isosceles triangle theorem here. And the fact that a rhombus, all sides are congruent. Okay, so we can say that the measure of angle CAD is equal to the measure of angle ACD. So 100x to the power of 6 plus 25x to the power of 3 is, plus 1 is equal to 36x to the power of 6 plus 9x to the power of 3. I'm going to set this equal to 0 by subtracting 36x to the 6. and subtracting 9x to the third, and we get 64x to the power of 6 plus 16x to the power of 3 plus 1 equals 0. This is a trinomial, so we're going to try out the trinomial factoring. Multiply the first and last term together, get 64x to the 6. Put the middle term here, 16x to the third. And looking for two numbers that multiply to 64 but add to 16. Well, we know 8 times 8 is 64, and 8 plus 8 is 16. So 8x to the third times 8x to the third will make this work out, because when I add them I get 16x to the third. When I multiply them I get 64x to the 6. Remember, when you add terms, the powers stay the same. When you multiply them, you add your exponents. So I'm going to split up my 16x to the third to 8x to the third plus 8x to the third. And I get 64x to the 6 plus 8x to the third plus 8x to the third plus 1 equals 0. Factor by grouping. Factor out a 8x to the third. What remains is 8x to the third plus 1 plus, I'll just factor out a 1. Both of these terms have a common factor of 8x to the third plus 1. And what remains is another 8x to the third plus 1. Don't stop there, because 8x to the third is a perfect cube, and so is 1. So this will factor to 2x plus 1 times 4x squared minus 2x plus 1. Okay, we're using the pattern for sum of two cubes, and same thing happens here. It's a repeat. Another 2x plus 1 times 4x squared minus 2x plus 1. The three-term factors, the ones I'm going to highlight, these are not factorable, and so you don't have to solve this. And then the two-term factors are exactly the same, so they're going to give the same answer. So really you only need to take one of them, set it equal to 0, and solve. And you get x is equal to -1/2, and that's your answer.